Okay, year 10. It was great seeing you again. Brought a touch of normality to this 15 weeks of lockdown. We got quite far on the mathematics on the booklet. It will be this week your responsibility to do each of the four, or to complete the worksheet. Any questions that you're struggling with, and contact me obviously. But there's four worksheets at the back there. They need to be submitted by Friday. You can do it beforehand, but you need to post them, a photograph on Google Classrooms. And once you've done that, you'll get a video of the solutions to do each of the worksheets. Now, we didn't quite finish the worksheet. No group did, so we were all at the same level. We all had the same lesson. We did get onto quadratics. You don't realise they're called that, but we'll come on to that now. I can't get rid of this thing here because I'm doing it from home, so you just have to bear with and just accept that that's there. It's not going to spoil anything. Anyway, you looked at the expansion of things, double brackets like this. If I just change my colour, okay, I don't know, x plus 3 multiplied by x, I don't know, minus 5. And you realise there were 4 steps to it, and every one of these 4 steps was a multiplication. So this times this gives you x squared. This times this, dealing with the sign first. Signs were different, so it's a minus. And x times 5 is 5x. And then moving on to this number, including its sign, that's a positive. It looks weird, but there you go. Plus 3 times by the x gives you a positive 3x. And then finally, the third step, dealing with the signs first, is a positive times by a negative. Different signs gives you a negative. And 3 times 5 gives you 15. You knew that in the exam that gives you 1 mark. All we've got to do is simplify this. And you're not changing signs or doing anything here. You are looking on the number line. You are starting, you can do this bit in your head, but you're starting here, minus 5, and you are doing whatever it tells you here. Now it's telling us to add 3, so you're climbing up 3, which will get us to minus 2. So you can do that bit in your head, just be careful, you're gathering the x's. So it gives you minus 2x when you combine these two, and you've still got a minus 15, and you've still got an x squared, and that is expanding these brackets. Now this here, we didn't get onto it, but this here is what we call a quadratic expression. It's a quadratic. So a quadratic is when the highest power of x is x squared. If that x squared wasn't there and you just got x's, it'd be a linear, what's called a linear expression. Okay, and we did some linear equations where we were solving them using the LND method last week when you came in for one of the lessons. But this is now a quadratic. It's an expression because it doesn't equal anything. Okay, it's not an equation. It can't be solved. It is just an expression. Now, if I went ahead and said, wrote this equation down here and said x squared minus 2x minus 15, for instance, and made it so it was an equation and said, where does that equal 0? What value or values of x where it will make this equal 0? Now with a quadratic, there is usually 2 solutions. Well, in foundation, usually 2 solutions, or a minimum of 1 solution where they're both the same number. I'll show you what I mean. Okay, what you have to do is you have to factorize this using the product and sum method. Okay, the product was minus 15 and the sum was minus 2, and it allows us to find 2 numbers that goes into the brackets. Well, we already know it's this. Okay, so when you factorize this using the product and sum method, you will get to x plus 3 multiplied by x minus 5, and that is obviously got to equal 0. If you knew what x was, x being a number, you'd put it in there, you'd add 3 to it, and it would give another number. It'd give you an answer for this. And same, if you put x in here, the number that you knew, and took 5 from it, it'd give you another number. Ultimately, you would end up with one number here, let's call it A, and another number here, let's call it B. And these 2 numbers will times together, and they've got to give you 0. Now the crux of this is to make 0 whenever you times two numbers together. The only way that is ever going to happen is if one of these numbers is 0. Either the A can be 0, or the other thing is the B could be 0. And what do I mean by that? Well, if I just scroll across a bit and just explain, if you do, I don't know, 6 times by 0, the answer is 0. If I did 0 times by 10, the answer is 0. So either of these numbers could be 0. Okay, so that's what I mean by that. Either one of these numbers can be 0. So A represents this. So what I'm trying to say is that either the result of x plus 3 can equal 0, or the other combination, the other possibility is B. B is this one. X minus 5 could be the thing that equals 0. So if I put in, if I go ahead and solve this, this is, as you've seen yesterday, it's a one-step equation. The only thing you should realize you've got to do is take 3 from both sides. So take 3, you end up with x must be the value minus 3. And that, believe it or not, is one number, one solution that you can put into here, square it, take away 2 times it, and take away 15, and I guarantee you'll get 0 as an answer. Or the other alternative is looking at this one, yeah, which came from B, which is this. And if you solve this, it's a one step. All you got to do is get rid of that by adding 5 to both sides, and you end up with another solution. Another possibility is when x equals, add 5 to both sides, you get 5. So there are two situations you get where a number squared, take away 2 times the number, minus 15 will equal 0. And those two situations are when x equals minus 3 or x equals 5. And I'll show you that it works if I just move across here and put it back into this equation. So I'm just going to put it back into there and put it back into there. Okay. What I'm doing, I'll just get the calculator out to speed the process up. I'll just put it in to here. So I'll put brackets around it. Okay. So I'll just scroll down. It was x is minus 3 and x is 5. So minus 3 and 5. So when x is minus 3, we'll do first of all, just to show you wouldn't do this, this is just me showing you that it works. So when x equals minus 3, so putting it in, you end up with, right, Casio doesn't deal with negatives very well, so we always put brackets around them, negative numbers. So minus 3, brackets, we're going to square it, okay, we're just replacing the x with our number. Minus 2 times, and we don't need to write times with these, you can just open the brackets and put your number that you're timesing, which is again a negative, which ideally should be in brackets anyway. So there it is, minus 2 times minus 3, take 15. And I guarantee when I press equals, that will equal 0. 0. Okay, now you can see that that works. Now when x equals 5, it should also work. Okay, so let's put 5 into the equation again. So all I'm going to do is replay, delete, and put positive 5 into there, square it, delete, and put positive 5 into there, and I guarantee I get 0. Okay, that also works. Now just to show you, and I can't exhaust all of this, but I guarantee any other number you put into here will never work. These are the only solutions, the two solutions that will work. Okay, so if I put them into here, let's just choose another number, I don't know, let's choose minus 7. If I choose minus 7 and replay and put it into this equation, it will not equal 0. In other words, it is not a solution. Minus 7 is not a solution. So minus 7, oops, sorry, delete. Okay, minus 7, come into there and delete minus 7, press equals, and you can see it gives a number 48. It is not 0. And if I did as many numbers as I want, doesn't matter where you go, if you do, I know, 21 and put 21 into there, that's the last one I'm going to try, it will not work. Okay, so put it into there, delete, and 21 into there. I guarantee x can't be 21 because it gives another massive number. It will not equal 0. These are the only two situations where it equals 0. Let me try and explain why this is. Okay, what is actually going on. Well, if I come back to this here, And if I looked at it as a graph, okay, and I let me change colour because I'm just trying to do an explanation here. If I let y equal this, okay, which is the result x squared minus 2x minus 15, this will plot what's called a quadratic graph, which creates a curve, a famous curve called a parabola. Okay, and this curve I can guarantee will look like this. It'll go down like this, and it'll be a nice smooth and come up like that. I guarantee that this will be minus 3 just here, and just here it'll be positive 5. It'll be these two solutions. Why? Well, you are setting y to be 0. That is the equation, and it's equal y, and you're setting y to be 0. Y equals 0 is a line that goes through the y-axis, the x-axis, along the x-axis. That is y equals 0. So where does the line y equals 0 equal our graph? So where does that equal that? Well, it equals it just here. So you can see why we get two solutions. Hopefully, when you get a quadratic and asked to set it equal to 0, there are different combinations of what can actually happen. This graph on this occasion looked like this, and it crossed here and here, and therefore there were two definite, distinct solutions. This graph, if I did another equation and asked you to solve something else, it might look like this and just touch there. Okay, so there'll only be one solution. Let's say it touches there at minus 2. Then when you solve this quadratic, just like I did here, okay, when you solve this quadratic and set it equal to 0, you will get the two identical solutions. You'll get x equals minus 2, and the other b, setting equal to 0, will also be x equals minus 2. So there's only one solution, yeah, when it just touches. Now there's another final case, and that is the graph might look like this, and it shouldn't do at foundation. If they're asking you to solve a quadratic, you might have a curve that looks like this, and it doesn't cross the y-axis, and therefore you cannot solve it. You'll get a maths error. It is impossible. So there's no solutions if the graph turned out to look like that. But we're expecting usually to cross just like this, and I've used two nice numbers so it works out perfectly. It won't always be nice numbers like this. It might have to be read off, and you might have to estimate where it is and just give a decimal answer. Okay, so that is the principle behind what you are doing when you are solving a quadratic equation. Okay, quadratic because you've got squares in it, and an equation because you've got equals, and we always set it equal to 0. Okay, and then we factorize, and we try and make that equal to 0, get an answer for what x might be, set that could be equal to 0, get an answer, and those are our two solutions. Okay, and the reason all this works is because of the graph I've just rubbed out over here. Right, we'll go to the next page and we'll try a second question. So if we were trying to do example 2, if the question was solve, because that's how it will come, it will simply say solve x squared plus x, and it will say minus 6, for instance, is equal to 0. Now remember what I told you the process is, okay? You know that this will create a graph, and it could possibly get two solutions, two values for x, okay, that work, or just only one solution, or possibly no solutions. However, the examiner shouldn't be asking any questions where there's no solutions. It'd be stupid to do that. But here we go. The process is you have to factorize this. Okay, you have to do that because you can't find the solutions otherwise. So remember from the other day, it is product is equal to this number here. You're trying to find two numbers that will multiply to make this. Okay, so minus 6. And then the sum is this amount of x is here. Well, there's a 1 there, remember, so it is positive 1. Now I've taught you to put the signs in, so you're very careful about choosing the right things. You know, if you factorize this, let's get my highlighter out, if you factorize this, you will get double brackets, because remember what I said, you get x squareds, x's and a number that should factorize back into double brackets. And on this occasion, because it equals 0, we now start putting equaling 0. Be careful, you only put that in, it's only an equation, and it's solvable if it's got equal 0. It's not one of those questions where it says factorize and it's just that, and that isn't there. You just factorize it. You wouldn't write this. Anyway, we've got this. We know x goes there and x goes there to make the x squared. And we've got to now find these two numbers that make this work and this work. So as I taught you, we look at the 6 and we write down all of the factors of 6 starting systematically at 1. So 1 goes into it 6 times. 2, yeah, 2 goes into it because it's even 3 times. And there's no other combination. Now when you times two numbers to make a minus, you should already know from last week that they've got to be different signs. A positive times by a negative, a positive times by a negative. And I told you you've got the mirror image as well, okay, which is 1, 6, 2, 3, and you can have it the other way around, obviously. That being the minus, that being the positive, that being the minus, that being the positive. Now, there'll only be one way of these 4 pairs that actually gives you a summation and adding these two numbers to make 1. And you must choose correctly, it is this pair here. This will actually give you, when you add those or combine those two numbers, 1. This here, be careful, is minus 1. It is not what we want, so you must be careful here. So, minus 2 goes into one of them, and it doesn't matter which one. And plus 3 I'm going to put into there. I could have put plus 3 here and minus 2 there, it doesn't matter. Now we're nearly there. Remember, that result times that result, A times B is equal to 0. And that will only work if either this one, A, equals 0 or B equals 0. In other words, x minus 2 has to equal 0 for this to work. Or the other alternative is the x plus 3 could be the one that equals 0. But one of them has to equal 0 for it to work. And all you've got to do to solve this simple one-step equation is add 2 to both sides, and you end up with x equals 2. And there you have the first solution. And take 3 from both sides on this one to give you x equals minus 3. Okay, you have now solved this quadratic equation. Okay, and that's all there is to it. You don't need to do this next step, and I'm just going to show you that it works. I'm going to put 2 back into here, 2 back into there, and minus 6, and show you it gives you 0. And I'm going to do that using the calculator. Okay, so brackets, I'm putting 2 into it. I'm then going to square it. I'm adding 2, so adding brackets 2, and I'm taking 6, subtract 6. It will equal 0. And likewise, if I put minus 3 into it, just replay, delete, negative 3 back into it, and put delete, negative 3 into it, and if I press equals, it will also equal 0. There are no other values I can ever put into here where it will equal 0. And I don't want to keep on doing this, but I'll put 5 into it, for instance. Delete 5, just a random number just to show you. It's not really a proof, it's just an example. It equals 24. It will never equal a 0 again. So again, this graph here, when you come to a bit of plotting and exercise on plotting, you will realize it will actually create a graph looking like this, where it crosses there at the negative 3 and it crosses there at 2. You don't need to know this yet, but that's in essence what this graph will look like, because we know where it equals 0 along there, we know that it is actually at x is 2 and x is minus 3. Okay, so there's another one that's done. Right, I want us to have a look at another one, and that is a slight extension to this. Okay, and if I say something along the lines of, I'm just going to give you these, there's 3 examples I want to give for sure, just to make sure that, as I said, I always give those are the most basic ones, those are the obvious ones, and you should be fine with it, ones I've just shown you. However, you might hit problems with ones that are going to try and catch you out. And here they are. So here's example 2. I think it's example 2 anyway. Okay, example 2. It will simply say solve, and it will say 2x squared, and it equals 72. Now, when you're solving a quadratic, if they're being awkward, you've got to make sure that wherever the x squareds are, whichever side the x squareds are going to go onto, either left or right of the equal sign, that they are positive. Now, x squareds are only here. They could be on both sides, but you've got to make sure whichever side they end up on, they are positive. They're only here on this question. So x squareds are going to stay on this side, and that means the other side must be 0. You can't have anything on here. Everything must be on the side with the x squareds on. That means we've got to get rid of this. Now, the only way you're going to get rid of that is by taking 72 from both sides. So I end up with 2x squared, take away 72, and now we've got the situation where it equals 0. So we've done everything we need to do there. Now, it's an equation. Now, bear in mind this is an extension. It is a tougher question. Okay. With an equation, you can times through an equation by any number you want, and it keeps the same, just gets bigger on this side at the same rate as it gets bigger on this side. Or you can divide through by a number. Okay, or you can add a number to both sides. It's those tipping scales, remember? So you're just keeping it perfectly balanced. You can do any of these taking numbers, adding numbers, dividing numbers, timesing numbers, the 4 operations, as long as you're doing it to both sides, and it keeps it balanced. So you can see that these two numbers have got 2 into it. So therefore, I can simply divide the entire side by 2 and divide this entire side of this equation by 2. 2 goes into there, well, just gets rid of that. You just end up with 1x squared instead of 2x squareds. 2 goes into minus 72. It goes half it goes into 36. And half of 0 is still 0. So I end up with an equation looking like that. Okay? A quadratic equation. Now remember, this should be ringing alarm bells. Okay, this format here should be ringing alarm bells. Right at the end of your lesson when you came in last week, or this week, depending on when you're looking at it, the 3-hour lesson we had, this is a square, this is also a square, and it is minus. It is the difference of 2 squares. So instantly you should know it goes into this format. Okay, you should know there goes an x there and an x there, and hopefully you remember how you find these two numbers. All you got to do is square root that. It's a square number. If you square root it, you get plus 6 and minus 6. Again, you could put a minus 6 there and a plus 6 there. So you've got the two solutions. You factorized it. You divided by a common factor because there was a common 2. I could just divide both sides of the equation. It's still the same. That is the same as that. The result of that is the same as that. The result of that is the same as that. Only because I did the same thing to both sides. Right? Again, either this number here, which we called a, doesn't matter, but this number here, the x plus 6, has to equal 0, or the other solution is this here, which is the x minus 6, has to be the one that equals 0. To solve this simple equation, we just take 6 from both sides, so you get x equals minus 6 is one solution. And the other solution here is add 6 to both sides, and we end up with x equals 6. So we've got two solutions, x equals minus 6, x equals positive 6. And again, they are the only solutions that will make this equation work, okay, where 2 times the number squared is equal to 72. There are no other solutions where it will work, and that's how you solved it. Okay, so there's the first example, remembering that you can divide both sides or times both sides or add both sides or take things from both sides of an equation, and to simplify it. In this simplest form, we can then factorize them away, and that was the difference of 2 squares. The next example I want to have a look at, so example 3, another one that's quite complicated. Well, no, no, I'll take it back. This one should be quite doable, I would hope. So you'll be asked to simply solve, okay, and it would be x squared take 8x plus 15 is equal to 0. Now this is, I hope, quite straightforward. The technique you should know is simply making sure this side equals 0, making sure this side's got positive x squared. Yes, it is, so nothing has to change, so that's great. The next thing we've got to worry about is factorising this. We know it will go into double brackets because you've got so many x squareds, so many x's and a number, and there's not a common factor you can pull out, so it has to be this. There's no common number or common letter in each of these three terms, so it has to be double brackets. Remember, it is product is equal to the number closest to it, which is plus 15, and the sum is equal to the minus 8. So we create a table, and we always start with the product, listing all the factors of 15, which is 1 and 15. 2 doesn't go into it, 3 goes into it, 5, 4 doesn't go into it, and then we start repeating ourselves. 5 goes into it, 3. So there's only 2 pairs of factor pairs that make it. Now, to make a positive, when you times a number by a number, they both have to be the same sign, both positive, or the mirror image, 1 and 15, 3 and 5, they can both be negative. That will also, if you do a negative times a negative, you also get a positive, as you saw in the lesson. Now, there's only one combination that's going to work to make minus 8. Choose it carefully. It is minus 3, minus 5. That's the only one that works. It is not this one. People usually, if they go wrong, it's here. That gives you positive 8. It is not what we want, and these certainly don't work. So x goes there, as you know. X goes there to make x squared. And put these numbers in any order. Minus 3 goes there, and minus 5 goes there. Now, to finish it off, because we're trying to find where will this equal 0, well, that will only work when either this number, x minus 3, equals 0, or the other possibility is this number here, x minus 5, could be the one that equals 0. So to solve this simple one-stepper, you add 3 to both sides, and you end up with x is the value 3. That's one solution. Okay, the other solution is add 5 to both sides, and we've got x equals 5, which is the other solution. So there's only 2 solutions to this, and that's when x is 3 or x equals 5. Okay, so that's a typical question, and I'm hoping that you can do that. Now, this fourth one is going to try and catch you out again. This is probably about as hard as it's going to get. So example 4. Now, it says 2x minus 5 all squared is equal to 49. Okay, now if you ever get a situation like this, I would start by, remember, you can add numbers to both sides as long as it's the same number. You can take numbers from both sides as long as you do the same both sides, keeping it balanced. You can times both sides by the same number, divide both sides by the same number. You can even square root both sides, and it'll keep it the same equation. But when you square root, you will always get 2 answers. Let me explain. If you've got 36 and you go ahead and square root it, you will always get the obvious one, which is positive 6, because you know that positive 6 times by positive 6 does in fact equal 36. But you'll also get a second answer, minus 6. And that's because minus 6 also times by minus 6 will give you positive 36. So when you square root, you will always get a plus and minus answer. Okay, positive 6 and minus 6. So coming back to this, we square root both sides. That's what we're actually going to do. We're actually going to do the square rooting. So if you ever get this situation, square root both sides, you end up with 2x minus 5 on that side, and if you square root 49, as I've just said, you will get a positive and minus 7. There are 2 answers it could possibly be. To finish it off, and I say it again, this is an awkward question, you would simply get rid of this first of all by adding 5 to both sides. Okay, I would stop there and I would write it separately if I were you. I would write down the 2 things that this is trying to tell you. And that is 2x minus 5 is equal to the positive 7. And the other equation that is hidden there is that the 2x minus 5 could in fact equal the minus 7. Okay, there are 2 scenarios we need to look at. The positive 7 and the negative 7, because we square rooted both sides. So if we go ahead and look at this and solve this as a two-stepper, add 5 to both sides, add 5, add 5, you end up with 2x equals 12. And then divide by 2 and divide by 2, you end up with a single x is equal to 6. And there is the first solution. You could add 5 to both sides here, so add 5, and this time you end up with 2x is equal to minus 2, and then we're going to divide by 2 and divide by 2. So x could equal minus 2 divided by 2 is minus 1. Those are the two possible solutions to do this equation. Okay, to solve this equation. I'm going to show you just one last example, just to make sure you're totally okay with doing these. It doesn't get any harder than these questions here. I mean that was straightforward, but that was again a catch. So example 2 and example 3 are well worth looking at and just considering and just trying to get your head around. They're very awkward and they're unlikely to be in the exam, but they could be. Okay, it's not impossible. Right, but it's certainly at the upper end. Right, this is example 5. Okay, so if I went ahead and asked you to solve, I'll just get my book out. Okay, if I said, yeah, okay, x squared. It will be. It's hard. I better say it as it should. It will say solve, and it will say x squared. I'm going to say plus 7x is equal to, and I'm going to say 18. Okay, so I just made up an equation just there. The process. So remember what I said. The first thing you've always got to do is make it so you've got everything on one side, doesn't matter which side it is, and a 0 on the other. When I say it doesn't matter, there's a catch to it. How you choose which side to get everything onto, you've got to make sure you've got positive x squareds, and these are positive. So everything has got to come onto this side, and you've got to be left with nothing on the other side. So we're after positive x squareds. So that's fine, it's there. So what I've got to do is get rid of this to make it 0. So take 18 from both sides, and I end up with x squared plus 7x minus 18, and that is equal to 0. And now I'm ready to solve. And how you solve a quadratic is you factorize the bit here, the expression here. Okay. So x squared plus 7x minus 18 can be factorized, and we know it's so many squareds, so many x's, and a number, so it goes into double brackets. And don't forget, it's an equation now, so it equals 0. We know that x goes there and x goes there. That's what gives us the x squared. We know that the product is the number that's closest here. It's minus 18. And the sum is plus 7, positive 7. Okay. Now we need to exhaust all the ways of making 18. That is starting systematically at 1. So 1 times 18. Does 2 go into it? Yep, 9. Does 3 go into it? Well, if you didn't know, 1 add 8 is 9. So you just add the digits up. And 3, it goes into 9. 9 is a multiple of 3. So yeah, 3 does go into it. 3 goes into it 6. You knew that anyway. 4, no, because you can't halve it and halve it again. You can't halve 9. Well, you can. It gives you a decimal. It has to be an integer. Does 5 no? Does 6 no? Yes, and it starts repeating itself. Now we get the mirror images as well. So remember 1 and 18, we just copy it out again. 2 and 9, 3 and 6. I call them mirror images. Maybe not a proper name for it, but it doesn't matter. To make a minus, the signs must be different when you times them. So we could have a minus and a positive times together. A minus times a positive. A minus times a positive. But you can have the reverse of that, which is a positive times a minus, a positive times a minus, a positive times a minus. Now the only combination out of these 6 pairings to make positive 7 must be chosen very carefully. It is this pair here. Okay, that makes positive 7. It is not this one here. If you combine these, it will give you minus 7, and we want positive. So I'm going to put these numbers in any order I want. So I'm going to put the minus 2 there and the plus 9 there. So we're nearly there. That result times by that result, A times by B equals 0. And that will only ever happen if either A equals 0 or this B equals 0. So x minus 2 is equal to 0, or the x plus 9 is equal to 0. And we simply solve this one-step equation by adding 2 to both sides, and we got x equals 2 is the first possible solution to this original equation, or we take 9 from both sides and we get the second solution, which is x equals minus 9. Okay, right, so I'm just going to figure out one more example just to make sure we're totally proficient at all these awkward ones. So example 6. Okay, so I'm just writing a question out just to make sure I can do it, that it works. Okay, so I've got 7x minus x squared is equal to 12. Okay, right, now to do this question, like I said, you've got to make sure you've got positive x squareds. Okay, everything needs to be here with positive x squareds and all the rest of the gumph and equals 0. If these aren't positive, then you've got to get it onto the other side to make it positive. And I'll show you what I mean. Okay, that's the catch here. X squareds exist here and they're negative. I want them all onto the side where they'll end up positive. So to get rid of these, if I add x squared to both sides, you'll notice that miraculously that jumps over and comes over to here and isn't a negative, it'll be a positive once it's over here. And you'll see that, look, the only thing that's going to be left here is 7x. And over here you'll have a positive x squareds and a positive 12. Then we need to get rid of that. So we take 7x from both sides, take 7x, and you'll end up with nothing on this side is equal to x squared minus, you'll have a 7x, and you'll have a positive 12 as well. So now we have in fact got our positive x squareds and nothing on this side. So I can rewrite that now, ready to go. Okay, I can just put it here. I can start the equation off by saying x squared minus 7x plus 12 is equal to 0. It's exactly the same equation, I've just turned it around. Exactly the same. Okay, so we've rearranged what they gave us, or what I gave you, and it's into the nice format with positive x squared on one side and 0 on the other. So all we're ready to do now is go ahead and factorize this. Well, there's no common number that goes into it all. There's no common letter that goes into these three terms, so it must go into double brackets. Don't forget the equals 0. To get the x squared, you need an x and an x. You should already know by now from practice that product is this number here, which is positive 12, and the sum is this number here, which is minus 7. And we must exhaust all of this, including the mirror images, to make sure we get everything. Starting systematically at 1 and 12. 2 goes into it because it's even, that is 6. 3 goes into it because 1 add 2 is 3, and 3 is a multiple of 3, so yeah, 3 goes into that, but we knew it anyway. I'm just testing that your knowledge about how to test a number for divisibility of 3. Does 4 go into it? Yeah, well, it goes into 3 times, so that's all the pairings, 3 pairings. Now to make a positive, you're also going to get your mirror images, so 2, 6, 3 and 4. So these can both be positive, 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 but they can also be a negative times a negative will still give you a positive. So negative, 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 negative. Out of these 6 pairings, there's only one pair that's going to make you minus 7, and that is this pair. And I keep on saying it, I've said it every time, be careful, it is not this one. That is positive 7. It is only that one. So the two numbers are x minus 3, I can put in there, and minus 4 in there. And I said the order doesn't matter, you put those in. That allows us to finish this question off. Either this number, the x minus 3 result, could equal the 0, or this number. Remember, a and b times together to equal 0, one of them needs to be 0, either that one or that one. So or x minus 4 could equal 0. Solve this one-step equation. You add 3 to both sides and you end up with x equals positive 3, and this one you add 4 to both sides and you end up with the other solution, x equals 4. So in fact there are again two solutions that you could put into this original equation. 3 and 4 will make that side equal that. There are no other solutions that will work. Right, by next week, I think there's 4 lessons. By Friday, the end of it, there are on the back of the worksheet you've taken home or you've had posted, there is a worksheet, 4 worksheets that need to be completed and, as I said, uploaded to Google Classrooms, to this Google Classroom. And once you've done that, you will get a video with the work solutions so that you can mark and correct your work. Okay, and it's essential that you keep on top of the practice because this is now module 14 and you don't want to be at a disadvantage in this time next year in the exams. Okay, but it was a pleasure seeing you and I hope that was of some use. Okay.